had some really fascinating discussions, certainly in my breakout room that I was in with Raj, and judging by the notes that I've received, loads of discussion elsewhere as well. So we're going to spend 10 minutes on each of the breakout room topics. Obviously, you don't know what they all were yet, so I'm going to give you a quick summary first. So in room one, we were talking about collision avoidance for automated transport. So the point there is that automated transportation is becoming commonplace, while intermodal interfaces between transport systems are also increasing. And in this scenario, we aim to explore how an automated multimodal transport system can be achieved with acceptable risks for collisions and the resulting accidents. So does that make sense, what we're discussing? So collision avoidance, lots of different modes coming together, and risk avoidance. So in room one, the key takeaway was that we need to understand the complete system and the policy legislative outlook before we start populating the world with the automated systems. So that may be a challenge indeed. So at the moment, we seem to perhaps be heading in the opposite direction. There's a plethora of systems hitting the roads and the seas and so forth. So come to Andrew Hussey first. Welcome, Andrew, to the conversation.
Yeah, thanks a lot. I've got thoughts about that stuff that you're just discussing.
So particularly on that finding, we should be understanding the policy legislative landscape and how this is all going to fit before we start putting those systems out there in the wild.
Well, the problem is that, there's a couple of problems there. I think one is that the policies or legislation at the government level aren't integrated. That's one sort of starting point. So you've got legislation, for example, that relates to roads, legislation that relates to rail, legislation that relates to air, but you don't have the integration of that legislation. And then, so that's at the sort of policy level, or legislation level. But and then it's the same thing when you come looking at this, when you're looking at the standards or at the development of these systems. As you were saying, if people are developing systems in isolation, then you're making implicitly assumptions or dependencies on the other modalities, which is maybe fine given we've got these long-standing reference histories. But when we start introducing multiple autonomous systems in the same space, you've got a different premise. So I think, yeah, you're right. There has to be a shift there away from that. But which maybe the world isn't completely ready for.
Okay, so I think I'll come to Chris next on that same question, as you perhaps had some experience dealing with government and policy and how that interacts with the systems engineering. What do you think about this idea that we should be understanding how the world will look with this transport before we start automating it and putting it out there?
Well, I think it's very interesting. It's a good point about the different regulatory environments and for each mode. But I also worry about complexity that we create when it's perhaps not necessary. You can see the advantages of an integrated multimodal approach, but also if we integrate it too far, the complexity goes through the roof. So I'm just thinking in terms of, we try and give enough information in advance to people now that they can, for example, take a train and know that their bus is going to be at the bus stop when they get to the station by a certain time, or vice versa. And that's fine. That's about information integration. But if we integrate even further between modes, so for example, someone was talking about, in one of the groups I was in, was talking about level crossings and the interaction between autonomous road vehicles and autonomous rail vehicles at level crossings. Yes, it would be really good to get some advanced information from each of those modes for the other one to take account of, but it doesn't half make it complicated. And that I worry about that, because we have a we do have a tendency to overcomplicate things. And I always use the example of the toilet door on passenger trains. Passenger train doors used to have a simple metal latch, and if you went in and moved the latch, you could see it was closed because it was a metal object against another metal object. But now it's computer controlled and you've got multiple buttons to press. And quite often people are sitting in the toilet with the door open because they pushed the wrong button. And that's an example, I'm afraid, of complexity where we've made things over complex for what is actually a really simple thing. So I think we need to watch that. That's all I'm saying. I'm not saying
Okay.
I'm not against multimodal interaction, but we just need to watch where the interfaces are, I think, and how we manage those.
Yeah, so I think that, yeah, that's clear. Yeah, we shouldn't run before we should walk, probably is the message there. And we do need to bring the legislators into the conversation, not just the technologists.
Yeah. I think we have to be clear of the advantages. So we have to be clear of why we're making it more complex. What's the benefit? What's the value? And be really clear that it's worth it because the complexity will be high. That's all I'm saying, really. Yeah.
Okay, so a related point came from room 4, who were also talking about collision avoidance. And their point were, their key takeaways was where all the elements are controllable, such as train priority setting, level crossings, automated train lines, reversing, that there are already existing policies and strategies that can be adopted. So the second point that room 4 came up with is that current automated systems are not always good at dealing with some of the slightly random edge conditions that humans can cause, like slowing down or failing to obey signs or legislation. So come to you, Mikkel. Have you had some experience with that in marine? Yeah, this idea that we can design these brilliant technology systems, but people don't always follow the rules.
Oh yes, definitely. We have experience, I believe, in many domains and also in marines. In marines, in maritime domain generally, there is, for example, just to make an example, fishing people that are probably the oldest stakeholder on the maritime space. Sometimes think they can, let's say, fish everywhere, just to make simple concept. However, nowadays, this is not the case anymore, absolutely, because there are a lot of activities which affect the maritime space. And therefore, what seems obviously that I'm free to fish everywhere is not true anymore. And it's again another, from some way, it's another example of the complexity that is growing. And also to make a little link with the previous question, what is really needed nowadays in this complex world is to, in my opinion, is to decoupling the technology aspect, which need as much information as possible, from the human interface, which need just the right information for their needs, because the risk now is to overflow the people with too much information, therefore getting confused.
Thank you. Yeah. So coming to Raj, the next point that was made in room 1 was about the need for understandable AI in the decision-making process when we're starting to automate systems. So do you have any thoughts on that?
So I'll explain, as I said in the meeting, I spend a phenomenal amount of my time just reading through the legislation that's coming through Europe. And when it comes to AI and data, there's very significant controls being placed on how you use and process data, how you do risk assessments with AI. But AI is always about, to me, it's always about machine learning. There's very clear patterns that industry has to adopt these due diligence processes to make sure what you're doing is working correctly, it's harmonized. And in the event of it causing injury, whether it's data loss or anything, there's more opportunity for you now to be taken to court and have actions placed against you. And the problem you've got with AI and things as they stand today is there's so many different standards for all these interconnected devices, and what they're doing in Europe is trying to say harmonize it. There's a very specific a long list of due diligence activities you're supposed to do when you're developing AI systems to prevent risk and any harm. And it's those protocols that, okay, they might not cut over into the UK, but there should be a general adoptance of those risks and those criteria that they're used in the EU, because they still apply with whichever context you're using and handling data.
Thank
Can't
you.
just ignore them. Can't just
Yeah,
ignore them.
yeah, for sure. Thank you very much. So some interesting discussions there from the collision avoidance topic. So we'll move on to the next topic now, which was about Crossrail. And the outline of the scenario there is that the benefits of systems engineering practice in large projects are not widely understood by senior project leaders. So this can lead to misaligned contracting and integration strategies, poor systems delivery governance, and poorly managed systems risk. And that can have a significant impact on project delivery. So the aim of this room was to discuss how the benefits of systems engineering can be promoted and clearly explained to system leaders, to senior leaders, to improve their ability to manage systems delivery. Now, the key finding in room 5 where this was being discussed was that you've got to have manager buy-in, and managers have to believe in SE for it to work. Chris Binns, you've got some direct experience of this.
Well, yes, 7.5 years of it now from the fit out stage. I have to say, the good news in terms of system engineering on the Crossrail program was the foundation that was set before my time. So the foundation was very strong. I joined in 2015, July 2015, and we'd got decomposed requirements. The contracts each had works information, which was very clear on what the specific contract had to deliver to make the whole. And we'd had those gates that I mentioned on the way down the V, where we'd made sure that everything was integrated, or my predecessors had made sure that everything was integrated at the stage they were at. Where it got difficult, though, is that the program kept going, kept saying we're on time, even though there'd been a year or more of delay in the civils works for very good reasons, difficulties with tunneling, ground conditions, all sorts of logistics and so on. But always the concept was, oh, it's okay, we'll be able to squeeze it up when we do the systems fit out. And unfortunately, that lack of realization of the amount of iteration, bringing so many systems together and integrating them, and some very close coupling of the systems. Those were the sort of key things that affected us in going up the right-hand side of the V. So we have extremely close coupled systems. I can give just one quick example of something that threw us during the traveling up the right-hand side of the V cycle. And that was that we have integrated into one traffic manager's control desk called TM2, all of the SCADA, the remote control equipment, both for the critical high voltage systems and for all of the rest of the pumps and other controls out on the stations. So what happened was, when we turned the HV on to do dynamic testing, so to have power for the railway, we needed those control desks to be reliable and able to be used to isolate power in an emergency and control what was there. But at the same time, we had a whole bunch of stations contractors saying, well, I just want to try this pump, and can I just modify the software for this, and just try this escalator and see if that lift comes through on that screen. And we'd integrated it too heavily. So in hindsight, we should have separated those areas so we could have an area that was under control and managed and config was set while the rest was testing. We ended up doing that by too late in the day, by realizing we could split, and our backup control center could become a test control center, and the main control center was the one that we kept with a very specific configuration. But we didn't realize that until very late in the program. So it's those sort of things, yeah, close integration.
Yeah. And understanding that at the outset is clearly very important in order to persuade those senior managers to buy in, I guess.
Yeah, and to plan it from the beginning. So it's very difficult to plan staging of the project at the end after you've run into a problem. Much better to plan it at the beginning. And if we'd set out to say, we've got 2 control centers, we'll test in this one and we'll manage in this one. That's the sort of thing could have realized earlier on.
Yeah, thank
in
you.
hindsight.
Yeah. So yeah, hindsight's a wonderful thing.
Oh, it is. Yeah.
So in room 2, they were also talking about Crossrail, and their key takeaway there was you need to choose language to communicate outside the systems engineering discipline. I can see Andrew nodding away. Andrew's also a railman. Just introduce yourself very quickly, Andrew. I forgot to ask you to do that before. And so,
okay, no worries. I'm the director of RAMS. That's reliability, availability, maintainability, safety for Hitachi Rail STS in APAC. So yeah, definitely, I'm interested in rail. Yeah, sorry, go ahead, Stephen.
So yeah, a comment on choosing language to communicate outside of systems engineering.
Yeah, you're asking me. That was a takeaway I took from that discussion. I was actually in that breakout room. So I was pretty active in there because that was a topic that I'm very interested in, systems engineering and communicating it to managers. Yeah, definitely. One of the things I wrote down, a note I wrote to myself, was that you have to use a language that makes sense to the project managers. And one of the topics that was one of the things that was being discussed was that the project managers can be speaking an entirely different language about the activities or phases in the life cycle than what the systems engineering guys are. So it's very difficult then to get an optimal outcome when you've got that mismatch. So and I think we've all seen that, of course. That's my thought on that.
Yeah, thank you very much. And it's interesting that the second point from room 5, who also discussed Crossrail, was almost identical to that. Now we've already heard from Chris about how they've put some wonderful lessons learned in there and published it on a website, and it's there for everybody to see. Very honest. So the third point that was made in room 5 was related to that, and looking to understand how we actually use lessons learned to resolve and help future programs. Mikhail, is that something you've been involved in? How do you actually make sure lessons are learned and not just observed?
Yeah, that's very, very important topic, and I am afraid to say that too often we didn't learn from the past. That's the real experience. However, a key approach for me is to try to figure out very few strong elements as a takeaway from any complex project, and embrace them into the future project. But they should be very simple, very atomic, very clear to understand from everybody, because otherwise anything that is slightly more complex need to be, there is a general tendency to discard, general tendency to think, oh, this happened in the project, but not to my project, not to my people, not to this context, and so on and so forth. So unfortunately, the reality showed that the same mistakes happen many times, and the recommendation I bring to from my experience is take away simple atomic concept and try to use them as much as possible.
Thank you, Mikhail. And Raj, same question for you. How do we make sure lessons are learned and not observed?
For me, it's always to make sure that when you're planning projects out, it's not just project manager led, because they're aiming at looking at deliverables on a milestones. Systems engineers have to define the task properly and consistently to the project managers, because often they'll just cherry pick. So in one sense, systems engineers will define with their deep knowledge of the things that need to be done, but that has to be programmed in systematically with a project manager, and someone with oversight can then make a decision: do we do this or this, and what does it affect the overall program? Because often you'll see seniors will just want to look at costs, aims, and objectives. If the costs go high, let's do something. If they overrun, what do we do? Throw more resource on it. But if you do it at the starting point and the plan's done to an agreed set that everyone understands that needs to be done, and it's of the depth required, that's the way I always worked. I always reprogrammed every project manager away from what they think to where they're supposed to, the way you knew it worked. And it happened in industry, and you put a bit of fat on. But then if you came in early on something that you thought was going to be late, that's better than coming in late consistently all the time, because that'll just piss everyone off. There's an element of systems engineering needs to be more vocal and take over the planning aspects as well when someone's trying to plan it out, and tell them in depth. I think that's always been the case for me anyway.
Mm-hmm. Thank you very much. Right, so time to move on to our final discussion topic from the breakout rooms, which was about marine transportation of hazardous goods. And the suggestion that we started off with there is that there's a lot of benefits to moving stuff by sea when they're hazardous compared to the land-based alternatives. And this role of marine in transporting hazardous goods may well increase with the clean energy transition to encompass movement of alternative fuels such as hydrogen and ammonia. But at the moment, there's many challenges at the interfaces when transferring loads from road and rail and pipelines and wherever else those hazardous goods may originate. So we suggested systems engineering has a significant role to play in developing a safe, secure and efficient transportation system network with those well-managed interfaces. So I'd like to focus on this discussion on the interfaces. It is clearly an essential role of the systems engineer to manage those interfaces, because that can't be done in the siloed traditional disciplines. So when we're thinking about moving hazardous goods, it's very rare that they spend all of their life on a ship, right? So they've got to come from somewhere. Let's say it's radioactive, or it's got to go on a truck, then onto a train, then onto a boat, then onto another train, then onto a truck, and then it's got to be moved within a facility. Whatever it is, how do we make sure that when we're thinking about moving hazardous goods, that we look at that full life cycle of the product movement? Mikhail?
Yeah, that's very much important and very much topic focus. The real challenge now is to integrate the land part with the marine part. It's very actual. And there are a number of initiatives. For example, in Europe, Europe aims to call 10 European corridors, which have exactly the purpose to facilitate integration between the rail system and maritime system along the Europe. Similar approach somehow have come from China as well, and many other countries. The challenge here is to integrate not only at a technical level, but also at, let's say, management or even political level. The interface between the domain, but also between the different borders that are either physical or political. And there is where we have to work more deeply. And there is one also topic I mentioned, different domains in my presentation, because the technology may be ready for smooth transition between marine and land. However, there are a lot of non-technology barriers that are as well need to be overcome. That's my recommendation. There are a lot of working on that, but still not a very clear picture in my experience.
Thank you, Mikhail. Andrew, same question to you. Yeah, I know this is something that you work with on a day-to-day basis. How do we make sure that we thought properly about the full journey of that hazardous good?
Yeah, I think we've got to come back to that point that Chris made in talking about Crossrail, that in Crossrail, if I heard rightly, Chris mentioned that in Crossrail there was a lot of overcomplication of interfaces and function, and obviously not willful, I'm sure, but with a negative consequence, I think. And I was going to comment here that in the context of this, these risks that arise at these interfaces, then one of the goals of systems engineering is to simplify function and interface, and And one of the activities that we engage in when we're making that simplification is to find the right mix of function between system and people. So, you know, if you put too much reliance on people, then you can create hazards. If you put too much reliance on the system, likewise, like Chris was saying, you know, amusingly about the toilet example, you can create hazards. So, you know, in all these cases, in both cases, you can go you can make something that appears to meet the overall overarching requirements, but doesn't meet the requirements the goals in terms of usability or safety. So I think this is the point. There's a very good book. I was going to mention it before when Chris was talking, and it popped into my head. A book that I read a long time ago, which probably many people know, from Norman, called The Design of Everyday Things, where he talks about exactly this. It's not in the context of big systems, but the principle's the same. He talks about not over designing stuff and making it fit for its function. So yeah, I think that's the goal we have to strive towards. Not saying it's easy, of course, but that's where we have to end up.
Thank you. So the next point that came from this discussion about hazardous goods was focused on hydrogen, and you know, whether it's ammonia or hydrogen or whatever other fuel that we're looking at. You know, quite often hydrogen's a part of the mix, and obviously there are a lot of risks with hydrogen, and there's a tension between, you know, whether we explore hydrogen or improve the energy density of batteries. So Raj, as somebody who deals with substances every day, what do you think about you know, what does a chemist say about moving these goods?
You've got loads of regulations. First, you have to watch out for the prior informed consent regulation. That's a global regulation, which means you can't just assume you can move stuff from one country to another. You have to make sure it's on the pick list. So it's on that one country that's sending it, the other country has to receive it and agree to it. You just can't move stuff like that. They'll be stopped at borders, inspected. Again, it's all the regulations that are coming in. You have to clearly identify the waste, the hazard material, because it has an impact on the country that's receiving it. And there's so many control measures. You just have to look at what you're transporting, the potential impacts, make sure it aligns to the country that's receiving it, because you can design the systems end to end, but the countries won't receive it if it's not acceptable for them. And it's like, there's so many different areas I could go into this, I can talk at will, but yeah, watch the regulations, because the chemical regulations will put constraints on, especially in Europe and even now in North America. And you just have to be careful of what you're moving.
And how is that handled at the interfaces, Raj, currently?
Currently, it's really bad, because the customs interface, the systems don't actually integrate that well in Europe. They've all siloed. But what I'm seeing is they're all going to integrate within the next 2 or 3 years. So anything, you just do one customs form, and automatically that will trigger an inspection that can then go to a market surveillance authority that looks at dangerous chemicals. Will just say, stop it, it's not coming in.
Yeah. Okay, thank you. And so fine, I'm going to come to Chris Binns for the last word. And I'd like you to comment on a topic that appeared in the key takeaways from both the marine and the collision avoidance topic, which was about how we manage risk and the importance of understanding the risk appetite and the attitude of risk from all the stakeholders, and particularly the end user, perhaps, but understanding that not everybody views the risk in the same way and puts the same importance on risk, and also that automated systems, you know, we accept less risk if it's an automated system making a mistake than if it's a human driver, for example, making a mistake. So how have you dealt with that on Crosswell, please, just in a couple of minutes?
Yeah, so well, it's a really interesting topic, and is dealt with by collaboration, really. So I mentioned briefly in passing in my note about the 6,114 hazards we've identified when we were bottom up reviewing our systems. We've closed all but 73, I think, of those now, and there's a handful left, you know, that we've got to work our way through. We've got mitigations for all of them, of course. And it is interesting, as you say. So if I think back to the days of dynamic testing, when we were, and I explained how we were constructing the railway and dynamic testing at the same time, there were 2,500 risk control actions in order to get a train moving at that time. And the meetings that we had with all the stakeholders to agree that were very lengthy indeed. It was workshop after workshop to get everyone on the same page. And as you say, it's very easy for individuals to have their own view of risk appetite, including, in my case, you know, in my role as chief engineer. In the end, the final signatory on the declaration of control of risk, but informed by hundreds of people in the organization and a really strong team. So I can't emphasize too much the need for collaboration, to hear stakeholders' views and to work through those views. And you have disagreements. You won't always agree. You know, we'll have one view as a project team pushing to get to a goal, and the end user will have a completely different view saying, well, hang on, I don't accept that. That's not going to be good enough. So yeah, so collaboration, risk workshops, working together through the issues and not expecting that any one individual is right. So very important to work through things.
Thank you, and a nice point to end on there. That, you know, it's a lot of systems engineering is about talking to people, not just creating technology. So that wraps up our session for today. I'd like to thank all our panelists for joining us.